In this video, we'll build and test two summing amplifiers using the LM358 op-amp, one inverting and one non-inverting, and then we'll measure actually what happens on the bench. We'll start with the inverting summing amplifier. Each input goes into the inverting input through its own resistor. The feedback resistor connects the output to the inverting input, and the non-inverting input is grounded. This works exactly like a normal inverting amplifier, just with more than one inputs. So let's build our summing inverting amplifier. I'll be using two inputs, one at 1 volt and the other at 2 volts, giving us a total of approximately -3 volts. First, let's add power to the op-amp. So connect the pin 8 to the positive rail, connect the pin 4 to the ground rail. Next, we'll add the 10k ohm feedback resistor between pins number 1 and 2. Now we'll create the first voltage divider for voltage input number 1. I'm using a 39 kilo ohm resistor because that's all I had, a 10 kilo ohm resistor, and then ground. From the midpoint, I'm taking a 10 kilo ohm resistor, a wire to create the summing circuit. Next, I'm creating the second voltage divider, so a 10 kilo ohm resistor from the ground rail, 10 kilo ohm resistor to ground, another 10 kilo ohm resistor to the summing network, then finally connect the summing to the inverting input. Now we'll add our measurement points. So we need ground, we need the measurement point for V2, need the measurement point for V1, and the measurement for the output. With our bench power supply turned on and our ground connected to our multimeter, let's measure the V1 input, which is about 1 volt, which is what we predicted. V2 input, which is 2 volts, which is what we predicted. The output should be -3. However, you can see it's not. This is because we can't give a negative output, so the voltage level is clipped as close to ground as possible. This is why inverting amplifiers usually need biasing on a single supply. We'll cover that in a future video, hopefully. Now let's build the non-inverting amplifier. So rather than rebuild this full circuit, I'm just going to modify this inverting one. First by removing ground from pin 3. I'm then going to take the summing input and put that onto pin 3. And then I'm going to place a 10k resistor between pin 2 and ground, creating our feedback network for the correct gain. All our measurement points are still the same. Now with our bench power supply on and set to 5 volts, V1 should be 1 volt approximately again, 1.4, that'll do. V2 should be approximately 2.3, so our output should be around about 3.6. 3.7, that's pretty close. So it's showing that this is working. If you'd like to know more, there is a link to the full blog post with diagrams, equations in the video description. In the next part of this series, hopefully we'll look at differential amplifiers. Instead of adding signals, we subtract them, which is the basis of noise rejection and instrumentation amplifiers. Really hope you've enjoyed this video. Thanks for watching.